This is BYU Math 112. In this video we will discuss textbook section 2.1, exercise number 6. The problem reads, if a rock is thrown upward on the planet Mars with a velocity of 10 meters per second, its height in meters t seconds later is given by y equals 10t minus 1.86 t squared. Part A asks us to find the average velocity over some given time intervals from 1 to 2, 1 to 1.5, and so on. We note below that the average velocity is given by change in position over time elapsed. So we have some time coordinates above. We need to match them up with some position coordinates so that we can find their average velocities. The way we're going to do that is use this notation, y at 1, to be the y coordinate when t is equal to 1. So we're substituting in 1 for t. So we have 10 times 1 minus 1.86 times 1 squared. Evaluate, we get that the y at 1 is 8.14. Next we look at the y of 2. So here we're substituting in 2 for t. 1.86 times 2 squared. Evaluate that. We get 12.56. Following a similar pattern, we can find the y at 1.5 is 10.815, the y at 1.1, 8.7494, the y at 1.01 is 8.202614, and lastly, y at 1.001, 8.14627,814. So now that we have all of our time and position coordinates, we can go through and find our average velocities. So again here, average velocity is the change in position over time elapsed. So using the notation they have up here on the top, we're going to find the average velocity from 1 to 2. And whenever we want to find a change in position or an elapse in time, we use subtraction. So we're going to write that as y at 2 minus y at 1 over the time elapsed will be 2 minus 1. We can substitute in the values we have up at the top. So we have 12.56 minus 8.14. Our time elapsed is still 2 minus 1. Subtract on the top, subtract on the bottom, we get, and then divide 4.42. Next, the average velocity from 1 to 1.5. So we'll take y at 1.5 minus y at 1 over 1.5 minus 1. Y at 1.5 is 10.815 minus 8.14 over 1.5 minus 1. Subtract on the top, subtract on the bottom again, divide them out, we get 5.35. So again, following similar pattern, we find that from 1 to 1.1, our average velocity comes out to 6.094. From 1 to 1.01, we have 6.2614, and from 1 to 1.001, we have an average velocity of 6.27814. And we are done with part A. Hooyah. Next. So on to part B. Part B asks us to find the instantaneous velocity when t is equal to 1. Well, the instantaneous velocity is found by looking at the limit of the average velocities as time approaches 1. So thinking about it in terms of the intervals we were looking at above that look like this as t is getting closer and closer to 1. So we look at the numbers that we do have. When time is equal to 2, We have that when t is equal to 1.5, when t is equal to 1.1, 1.01, 1.001. So we have that these numbers are increasing, but then as our decimals get a little smaller and a little smaller, the amount that it's increasing kind of tails off. Part B asks us to estimate, so estimate. Our instantaneous velocity is going to be somewhere in the ballpark of 6.28. And there's number 6.